Here is 3726. A uniform film of oil, index of refraction 1.31, is floating on water. When sunlight and air is incident normally on the film, an observer finds that the reflected light has a brightness maximum at lambda equal to 450 nanometers and a brightness minimum at lambda equal to 600 nanometers. What is the thickness of the oil film? For this maximum and this minimum, we don't really know what the order number is. It's not given. So that is an extra challenge for us. But we do know that we have a film on water, and we're going from air, so our first index is going to be 1.0. As we go to the oil film, that index is 1.31, and the water is 1.33. So as light comes in, reaches this first interface, we're going from a lower index to a higher index, so we'll have a phase reversal there. And then for this refracted light, as we hit the second interface between the oil and the water, we're going from a lower index to a higher index there as well. So there will be a phase reversal on that interface as well. So we're going to have two phase reversals. Left it to its own devices, that would keep us in phase. So we just want the path length within the film, the oil, to be an integral number of wavelengths in order to get maximum. So for our maxima, we want that 2nt, that's called T1, is equal to an integral number of the wavelengths that correspond to the maxima that we saw. So we would say that the thickness is equal to m1 lambda 1 over 2 times the index of refraction of the oil. So this is equal to m1 times 450 nanometers divided by 2 divided by 1.31. And what is that equal to? 450 divided by 171.76. So we have 171.76 m1. m1 being an integer. Don't know what that is yet. For minima, we would have that 2n, let's say thickness T2, is equal to some integer number, m2, plus 1/2 times lambda 2. Solving for T2, we have T2 is equal to m2 plus 1/2, and we observed this to be at 600 nanometers over 2 times 1.31. So that is equal to what? $229 times m2 plus 1/2. Well, it should be true that thickness 1 is the same as thickness 2. So we should have that 171.76 m1 is equal to 229 times m2 plus 1/2. So, let's see, 171 divided by 229 is 0.75. So I have that 0.75 m1 is equal to m2 plus 1/2. m1 and m2 are both integers, so what integers do we need to make this work? In other words, 0.75 m1 is equal to m2 plus 1/2. You know, if m2 were equal to 1, then I'd have 1.5 on the right, and that would make M1 equal to 2. So that works. We just found two integers that worked. So my M1 is 2, my M2 is 1. To find the thickness, I just have to plug into one of the equations. T1 is equal to 171.76, and now times M1, which is 2. So that's going to be 343.5 nanometers. So that is the thickness of our oil film, 343.5 nanometers. If I plug in 1 for M2 in the other equation, I would get the same thing. 343.5 nanometers is the thickness of our film.